I apologize in advance for the errors in this notes packet, but let's fix some of these errors. We are going to be focusing on this equation, y equals log base b of x minus h plus k. This graph has some specific characteristics. The first one is it has a vertical asymptote, and it is not at x equals k. It is a vertical asymptote at x equals h. The side-to-side movement is going to tell us where the asymptote is going to be. And in the formula, it says minus h. So think about the opposite of whatever you see in the parentheses. That's going to be the asymptote. This is also more difficult than it needs to be. Once you know what the asymptote is, your domain is going to be x is greater than whatever your asymptote is. And the range will be all real numbers, which we can use the abbreviation, write the word all and then a capital R with a double stem to mean real numbers. Most of us have access to a graphing calculator that has the log base feature. So in your graphing calculator, if you can push alpha window and it pops up that little menu, then you have the log base feature. However, if you are using a scientific calculator or an older graphing calculator, you don't have that feature, and you need to learn how to do the change of base formula. And it's worth everybody learning how to do this, because at some point you might be using a scientific calculator and you can't do log base 2. So if we're trying to do log base c of u, you would use the log button on your calculator, which is base 10. Do log button of u divided by log button of c. So whatever number is big inside the log, that one goes on top. The base goes on the bottom. So using any calculator, let's do log base 6 of 15. Using change of base, we would do log button 15 divided by log button 6. So let me pull up my calculator. And let's do log button 15, close your parentheses, divided by log button 6, close your parentheses. You should get 1.511. Now, if your calculator does have the log base feature, I want to show you that this is the same. If I do alpha window and then select option number 5, my log base, and type in log base 6 of 15, notice that I get that same decimal, 1.511. So using this change of base formula with the log button, or using the log base feature in your calculator, you should get the same thing either way, 1.511. How would we set up log base 3 of 7? Somebody be brave. How do we set this up? Log 7 over log 3. Type that into your calculator and see what you get, and then try setting up and calculating log base 4 of 9. Check to make sure. Did you get 1.771 and 1.588? Okay. Now, it's important to know this change of base formula, especially if the calculator that you are using doesn't have the log base feature. So if you're using an older calculator, to type in this log into your y equals, you would need to type in log button of x minus 2 divided by log button of 2. Make sure you close your parentheses, and then plus 3. So if you have an older graphing calculator, that's what you're going to type in the y equals. If you have a newer graphing calculator, you can use the log base feature. So in my graphing calculator, first go to y equals so we can graph. If you're using the log base feature, I'm probably going to write this on the board somewhere. It's alpha window number 5. That's the keystrokes to get that log base. Alpha window 5. So if you watch on the calculator, alpha, that's the green button. Window, that's the button just to the right of y equals. It pops up this menu, and then you push number 5,
I can't find the window.
and it gives you log base.
It literally says window right next to
Oh.
Whoops.
I know, but like I was looking for an
Log base 2 of x minus 2. Sorry, you don't have to type in parentheses. Get out of your parentheses and then type in plus 3. And I'm going to show you, if you have an older calculator, you would do log button x minus 2, close your parentheses, divided by log button 2, close your parentheses, and then plus 3. Both of those are the same. If you have a newer calculator, you're going to do the one on the top using alpha window number 5. If you have an older calculator, you'll do the second one, log of x minus 2 divided by log of 2, and then add 3. I'm going to clear that one out. Okay, and then we can push our graph. When we look at the graph, we can see that the asymptote is 2, but does it surprise us that our asymptote is at x equals 2? We can see our asymptote right here inside the log. Because it says x minus 2, that means right 2, so your asymptote is at x equals 2. What does that mean your domain is? X is greater than 2, and our range, that's the easy one, all real numbers. Okay, now, here's what I've had people do. They know their asymptote is 2, so they just do this. There, it's graphed. Do you think that's going to fly? No. Because we are using the graphing calculator, go into the table and find some points to graph. First, I want to talk to you about all of the errors that you see in the table. The domain says x is greater than 2. So if our x value is smaller than 2, it doesn't work. That's why you see the errors in this table. Remember, you can move the table up and down. So what points do you think we should graph out of this calculator? 3, 3, 4, 4, and 6, 5. So 3, 3, 4, 4, 6, and 6, 5. If all I do is put these 3 points on the graph, it's still a little bit confusing how I should connect them. It is important to put some sort of guide for yourself where your asymptote is. Then you can look at the graph and see that it gradually continues up to the right, and to the left it curves toward your asymptote. It can look like it's touching the asymptote because the thickness of your lead makes it impossible to not touch the asymptote, but make sure that you do not cross the asymptote. All right, I would like you to pause the video and try number 2 on your own. Type it into your calculator, find some points, find the asymptote, the domain, the range, and get it on the graph. Okay, personally, I like to do the asymptote and start the domain and the range before I do anything else. So I notice that in the parentheses it says +1. The opposite of that is -1, so my asymptote will be at x equals -1. Which means my domain will either be x is greater than -1 or x is less than -1. So I'm going to put greater than for now because it's usually greater than, and I'll talk about when it's not. And my range is all real numbers. In the calculator, in y equals, alpha window, number 5, log base 5 of x plus 1. If you're using an older calculator, here's how you would type it in. You would do log button x plus 1, close your parentheses, divided by log button 5, close your parentheses. So those two lines mean the exact same thing. Okay, here's my graph. And you can definitely see the asymptote at -1. So I'm going to draw in my asymptote at -1. And then for points, 0, 0 is the first point I'm going to use. And then 4, 1. Do you see why I'm not picking these other points?
Yeah.
Do you really want to graph decimals? However, if you try to find a third point, it's like 20 something. It's a ways. So then I'm probably going to pick like 6 or 8. Let's do 6, 1.2. Okay, now to check your domain and range, if you look at the graph, if your graph is to the right side of your asymptote, it is greater than. If this had been flipped and was over here on the left side, then it would be x is less than. So only if it flips over to the other side of the asymptote do you flip your domain symbol. Okay, let's plot these points. 0, 0. 1, 2, 3, 4, 1. 6, 1.2. So this is going to increase very slowly on the right side. On the left side, it's going to curve down toward that asymptote. It's a weird little graph.